So the next question is derive the expression for VGS, ID, VDS, VD and VS for a voltage divider bias circuit using FET. It is from January-February 2020 question. Okay. So what is given, you have to find out the parameters, and the circuit is a voltage divider biasing of FET. So let me give the diagram of the voltage divider biasing. So voltage divider biasing means across the input you will be having a voltage divider, right? R1 and R2. Across the drain you will be having RD. So this will be your gate, drain and source. So stability resistor RS. Okay, so both will be grounded, and here both will be given to your supply voltage VDD. So in the input and the output you will be having coupling capacitor, right? So with VICC. So if we want to draw the DC equivalent analysis, now you will be including only your supply, DC supply, right? So your DC equivalent circuit will be DC equivalent circuit of the same diagram will be VDD, that is you will be having your RD, right? And you will have your source resistance RS, which is grounded. Across the input you will be having your voltage divider circuit R1 and R2. So this will be your DC equivalent circuit. So now if you want to find out all these values, you have to do only one step, that is apply Kirchhoff voltage law across the input loop as well as your output loop. So first case 1, let us take applying KVL across input. Input means through your, what will be your VG? The VG will be, since it is a voltage divider, the voltage VG will be across your R2, right? So this is going to be your loop. Okay, so this will be your input loop. So here you will be having the junction plus to minus VGS. This will be plus to minus VRS. So what will be your current flowing? This will be your current ID flowing. The same current ID flows here also. Okay, so this is going to be your input loop. Okay, so what will be your VG? Before applying Kirchhoff voltage law, you should know what is your VG value. So you know that by means of voltage division rule. Voltage division rule, what will be your VG? VG will be equal to your total supply voltage, that is your VDD, into the resistance across which the voltage you have to find out, R2 divided by total number of resistor. Okay, so VG will be equal to VDD into R2 divided by R1 plus R2. Now if you apply your Kirchhoff voltage law, what will you get? So let us start from VG. Okay, here it is plus to minus. So minus to plus. The loop current flow is through this direction. So minus to plus. Take the second polarity. So plus VG, then plus to minus. So what is your polarity? Take the second polarity, that is minus VGS. Here also it is plus to minus. So take the second polarity, minus. What is your VRS? Current into your resistor. ID into RS is equal to 0. Now we have to we will find what is your VGS. Okay, that is your first parameter. So what will be your VGS? Bring VGS to the other side. So you will be getting VGS is equal to VG minus ID into RS. So this is going to be your first equation. VGS is equal to VG minus ID into RS. Okay. Now you have found out what is VGS. From the same equation, can you find out what is your ID? Because already you have ID. So VGS, bring this VG towards the other side. VG is equal to minus ID into RS. So let us just reconfigure it and take what is ID. ID is equal to ID into RS is equal to VG minus VGS. So what will be your ID? ID is equal to VG minus VGS divided by RS. Okay, so this is going to be your second value. ID is also found out. Okay, now here you have to find out VDS, VD and VS, all is in the output loop, right? So applying KVL across output loop, what you will be getting? Output. So here the output is through this way, right? So here you have plus VDD. Here it is again plus to minus. So take the second polarity, minus ID into RD. Here you have plus to minus, the voltage is VDS. So minus VDS. Here it is again plus to minus. Minus ID into RS is equal to 0. You have to find out VDS. So what will be your VDS? VDS will be equal to VDD minus ID. Can I take it as common? So ID, what will be your value? RD plus RS. So VDS is equal to VDD minus ID into RD plus RS. This is your VDS. Now what will be your VD? VD will be equal to VDD minus ID into RD, right? VD is equal to VDD minus ID into RD. And what is your VS? VS will be equal to, what is your value? Current into your resistor, same current ID into RS. So these are the different values. Only two cases. Apply KVL across input loop and apply KVL across output loop. You are going to get the complete equations.